All right, here I'm going to go over this worksheet that I assigned, and I understand that this is difficult, it's not easy to do, but I'm going to maybe perhaps give you some more tools and ideas and hacks, whatever you want to call them, to help you out with this. All right, so here we have a question. So we're just we're slowly building up. I'm going to add one more layer after we've done a bunch of these questions to be able to fully answer this question, which will be to optimize our answer to come up with the best solution. Okay. Okay, a sports store has a revenue or profit or income of $180 on every snowboard and $120 on every pair of skis sold. The manager's goal is to have a total revenue of at least 1,920 a day from the sales of these two items. The store has enough room to store at most 15 snowboards and skis combined. And I'm helping you out a little bit. Let X be the number of snowboards and Y the number of skis sold. State a possible combination of snowboard and ski sales that will meet this goal. You have to graph it, okay? And I'm telling you here what to do before you even go ahead and do this, okay? So you have to graph this and basically go through the steps that we've covered, okay? So you can look at it in sometimes some students like to make charts, okay? So for example, if you first of all we'll say that X, right, is the number of snowboards and Y is the number of skis. And obviously we need both of them to be positive, and we should also make a note that this is discrete data, meaning you can't have part of a snowboard, right? It needs to be in whole numbers. And so the first part, we're given basically the coefficients for X and Y, and that there'll be a restriction on there is a restriction put upon your revenue, your profit. And there's also a restriction put on the total number of skis and snowboards combined. And so what we will do here is make a bit of a chart, okay? So we'll have X and Y, okay? And so these are our variables, and we know that the revenue, right, is 180 for a snowboard and 120 for a pair of skis. Okay, so we start making our chart here. And this could go on a bunch of times. It could be talking, I know that you'll be getting questions on like how much time is spent on on certain step along the manufacturing process and so forth. So if it's stitching time, if it's cutting time and so forth, which we'll see later, you just keep adding to this, right? And so also basically the number of, right, number of items. So in this case there's not much else here, there's nothing else, so we'll just leave it at that. This is our chart, this is our variables, and this would be X and Y, right? So you have your chart set up, and that's our starting point. Now there's a restriction on revenue, right? At least 1920 to be sold, okay? And there's also a restriction on the number of snowboards and skis combined, right? At most 15, like if you were to consider those two items, right? So it's just organizing, right? Like that, the fact that the dollar amount will go with the amount assigned to each variable, and then simply speaking of the total amount combined just applies to the X and the Y. So you basically get your equation out of these two without any coefficient other than 1, right? So I'll come up with my inequality here. I know that X plus Y that can be at most 15. Okay, so that's, I get that looking at this column here. Then I will address the revenue, okay, which I will put aside here. 180 for every snowboard plus 120 for every pair of skis. You want that amount, because these are dollar amounts, you want this to be at least 1920. So 1920 or greater. All right. So those are the only restrictions put upon you. Okay. And they could have added another layer here, right? Like wants to sell, because you make the most with snowboards, you know, the owner wants to sell at least 10 snowboards, right? So out of the 15, you know that at least 10 of them would have to be snowboards. But they don't say that, so this is it. There's no other restriction. You don't see any other at least or needs to make at least this many, or right? We just have a restriction on the combined quantities and on the revenue, on the profit. Okay, so here this is easy to get our intercepts from. Okay, rewriting it, we get negative x plus 15. Over here would be a little different. X-intercept, y-intercept. Just have it organized, right? 180 x is equal to 1920. Divide both sides by 180. And you get, and there you have your x and the y-intercept. So let's rewrite this. 1920. And divide everything by 120. Y is greater than or equal to, that ends up being, you actually get 1.5 exactly, negative x. So then it's okay to write it as a decimal plus 16. Okay, so there you have it. So we will say that it's solid, and what we're shading above is true, so we shade below. Let's make those two notes there, and this one solid and below is true, so above we'll shade above. So it's just telling you what kind of line and that we're shading above. So there you have your all the information you need for a graph. And remember, this is a word problem, so we stick with this. And you have your x and y coordinates, so make sure you label number of snowboards, number of skis. Okay, label that. Let's come up with a good scale. So for my x, I need to get to 15. That will take care of both of these x-intercepts. So let's see if I make it nice and big. So 5, 10, 15. That'll work. And then if you want to have in between, just to have a reference, you make little markings, cutting those in half, right? And if you wanted to go up by 4, that's fine. And then for my y, I need to go to 16 here, 15 there, so at least 16. So I'm going to go, maybe go up by 4. So 4, 8, 12, 16. That worked out pretty good. Okay, so graph the first one. 15 would be right about there. 15 is here. Solid. Oh, what happened there? Negative x plus 15, and then 10.67, which is just after this, and 0.16, which should be just above that. And you draw your line there. And it's okay to sometimes do this. So this is y is greater than negative 1.5x plus 16. So make sure you label those lines. And so let's see. This one we shade above. So let's follow that line. and just shade everything above, eliminate, right? That cannot be solution because it doesn't work for that equation. And this other one, it says shade below. So it's this one here. So we're going to shade below, right? All the way, so everything is gone. So this is your solution region. And we've got 1, 2, 3 corner points. Let's do the ones we can read. 10.670 and 06, no, sorry, 15.0. And that one, which I will find, which is 1 second, that one is 213. And just make sure it kind of makes sense. There's 2.5 right here, so 213, it does make sense. Whole number, not whole number. So we're gonna 10.67 is here, so we're gonna bump it up to 11.0, okay? Because of the discrete data. So make sure you write this and that both, okay? Same here, if that corner point had been decimal, write down everything to 2 decimals and then round it later. Okay, so you have your solution, and we state a possible combination, right? A possible combination would be to sell, let's try this one here, 2 snowboards and 13 pairs of skis. That's one possible combination there. And so anything in here would have worked. You could have picked 15 snowboards, no skis. That's up to you. But this is just a possible solution, so you can't really, unless you pick something that's clearly in the shaded region, which is our false region, that would be wrong. Okay, so just keep that in mind. That's it for this. I'll do the next question on a different video.